with XtraBackup. Alexey is a member of the development team at Percona and is the core developer of Percona Server and XtraBackup. This talk will cover basic operations such as tasking full and incremental backups, restoring from backups, and setting up replication slaves, as well as advanced and recently added features such as streaming and compressed backups, parallel operations, and partial backups. Alexey?
Yes, thanks. So hello, everybody. Good morning. I'm a software engineer at Percona, working mostly on Percona XtraBackup and Percona Server. So I'm the guy responsible for most new features and bug fixes implemented in XtraBackup over the last year and a half. I think I'm also responsible for a couple of new bugs. And in this talk I'm going to provide a technical overview of the features available in XtraBackup and explain basic use cases. What is Percona XtraBackup? It's an open source hot backup utility for MySQL, and MySQL in this context means three most popular MySQL flavors. There is the MySQL server itself, which is provided by Oracle, Percona Server, which is a MySQL-based server developed by Percona, and MariaDB, which is another MySQL-based server developed by Monty Program. For every project, XtraBackup supports basically all versions that are currently being used and supported by the corresponding vendors. So for the standard MySQL server, XtraBackup supports. For the standard MySQL server and Percona server, we support all versions from 5.0 to 5.5. And in MySQL 5.1, there are basically two versions of NETWAYS storage engine, the plugin and the built-in, and they're both supported. And for MariaDB, we support versions 5.1 and 5.5. There are no serious problems with supporting versions 5.2 and 5.3, but there's a minor version detection bug in XtraBackup, and those versions are just basically not detected correctly, which is of course a minor thing to fix. I'm going to fix this bug soon, so if you're using MariaDB 5.2 or 5.3 and need it supported by XtraBackup, you can expect it in the near future. As you know, MySQL supports multiple storage engines. So here's a list of storage engines supported by XtraBackup. It supports hot, that is non-blocking backups for InnoDB and XtraDB. XtraDB is an improved version of InnoDB developed by Percona. It also supports MyISAM, Archive, and CSV storage engines. But since those storage engines are not transactional, the only way to create a consistent backup of those tables is a temporary read lock. I will be talking more about this later. And speaking of other storage engines available for MySQL, we haven't tested them, but they may work if they support flush tables with read lock. That is, if they can be temporarily locked for queries to create a consistent backup. Now, speaking of supported platforms, we are pretty much focused on Red Hat because that's what the majority of our customers uses. We test and regularly use XtraBackup on Red Hat and derive distributions like CentOS or Oracle Linux. But we also have a big user base on Debian and Ubuntu, and that's why we also run tests on those distributions and provide binary packages for them. We are not aware of any problems with other Linux distributions, but we do not provide any binary packages for them. So if you use anything other than Red Hat-based distribution or Debian-based distribution, you have to build from source code. We also made an experimental Windows release. We get requests for Windows support quite frequently, probably because some people prefer to test the tool on their laptops or desktops before putting it into production. The Windows binaries for XtraBackup are known to work, but they have not been tested in production environment, hence the experimental status. We're also going to provide regular releases for Solaris and macOS 10, because we get requests to support them every now and then. And regarding FreeBSD support, we used to provide FreeBSD binaries in the past, but there was like one FreeBSD download per year, so we decided to abandon this platform. On the other hand, XtraBackup should work on FreeBSD if you build it from source code. We just don't test it as a part of our release cycle and don't provide precompiled binaries anymore. Okay, now let me explain why you need XtraBackup in the first place. That is, why can't you just copy files with CP or rsync or your favorite file manager? The reason is that the way database servers work with data files is much more complicated as compared to most other software. A database server usually uses both memory and disk storage to store data, and data on disk is usually not in sync with data in memory for performance reasons. Let's take NetDB for example. When a query updates data, it is only updated in memory. It is not immediately updated on disk. The update on disk may happen sometime later, and instead of updating data, NetDB makes a record in the redo log. But why do we need redo logs? We need redo logs for crash recovery. At some point, the system may crash, and if it crashes, the updates written to memory but not to disk are lost. But we still have them in redo logs. So when NetDB starts after a crash, it performs the recovery procedure. The procedure is to apply records from redo logs to data files. That is, we basically redo updates that made it only to memory but not to disk before the crash. And the idea of backup is very similar to what NetDB does on recovery. That is, during the backup process, we are copying data from disk to backup storage, and at the same time, we are following redo log updates and copying them to the XtraBackup log file. Which means by the end of the backup process, the XtraBackup log file will contain all updates to NetDB tables made while the backup was in progress. So we can use that log to replay all those changes to get a consistent snapshot of NetDB tables corresponding to the point in time when the backup had finished. And this process of applying updates from the XtraBackup log file to the backup files is what XtraBackup does on the second stage. This stage is also sometimes called preparing a backup, because after applying the log, the backup becomes consistent and is ready to be restored. So the backup logic in XtraBackup is essentially identical to the NetDB recovery procedure, which also means that we can reuse NetDB recovery code. And that's what XtraBackup does. During the second stage, during the when preparing the backup, it essentially starts a mini NetDB instance to perform recovery. Now let's look at the distribution structure of XtraBackup. So all binary packages contain the following files. We have three XtraBackup binaries: XtraBackup, XtraBackup 5.1, and XtraBackup 5.5. These binaries handle everything related to NetDB data files. That is, copying NetDB redo logs and data files and verifying their integrity during the backup process by calculating checksums for NetDB pages. That is, XtraBackup will refuse to create a backup of corrupted NetDB tables. And these binaries also also apply logs on the second backup stage. The reason why there are three binaries is that different NetDB versions may have differences in the on-disk format, on-disk data format. So the XtraBackup binary handles, is compatible with XtraDB in Percona Server 5.1 and NetDB plugin in MySQL 5.1. The XtraBackup 5.1 binary handles data files created with the built-in NetDB version in MySQL 5.1 and also the older versions like Percona Server 5.0 or MySQL 5.0. And finally, XtraBackup 5.5 can handle data files created with version 5.5 of Percona Server or MySQL Server. And then we have InnoBackup X, which is a Perl script, and it's a wrapper around XtraBackup binaries, which handles everything else, like coordinating with the MySQL server to detect its version, for example, and select the appropriate XtraBackup binary. It also copies non-NetDB data files like MySQL tables, for example, and FRM files. And it also backs up various meta information from the server, like binary log position. And there's also the XBStream binary that should be used with streaming backups. I will cover this later. Now, let's look into the backup process in more detail. But first, let me explain what has to be backed up. So every MySQL data directory contains a bunch of various files created by different components of the server. For example, IBD files contain InnoDB tables, and there is IB data 1, which contains the InnoDB system table space. Then there are FRM files containing table definitions. There is information about the table structure. MyISAM files are stored on disk as MYD files containing data and MYI files containing indexes. And even if you don't use MyISAM to store your data, which you really shouldn't, you still have MyISAM data. You still have the MySQL database containing system MySQL server tables. They're stored as MyISAM tables. And there may also be additional files like trigger definitions and tables created by other storage engines like Archive or CSV. So to get a consistent backup, we want to have a snapshot of all those files at a certain point in time. So here's the basic logic of a backup. When the InnoBackup X script is used, it performs the following actions. First of all, it starts the XtraBackup binary, which in turn starts to copy the InnoDB log and InnoDB tables. After the XtraBackup binary has finished copying InnoDB data files, it performs the following actions. It connects to the server and issues the flush tables with read log statement to log all tables and prevent any further updates to the database. After that, it copies FRM files and non-transactional tables. Then it records the binary log position. And finally, it unlocks tables to allow table updates. Now let's take a closer look at the flush tables with read log statement and steps 3 through 6. So we copy FRM files and non-transactional tables after we log tables with read log, and we also store the binary log position when the tables are logged. And what it means is that after the flush tables with read log statement, no clients can execute queries that change any data. And the statement also closes all tables, which means it first has to wait for all currently executing queries to finish. The statement also blocks all commit statements for the same reason, that is to prevent any updates to data. But why do we have to do that? Why do we have to lock all tables and prevent any updates to them? Let's consider the following case. We have to copy many FRM files, and while we are copying table 5, some client modifies table 1 with an altered table. That is, it changes the FRM file corresponding to table 1. And if we allow that, we get an inconsistent backup, because the backup will contain the old definition for table 1, while the actual data may correspond to the new table structure. So with flush tables with read log, all DDL and all DML statements will be blocked until we complete the backup and unlock all tables using the unlock tables statement. And it may be obvious, but the same problem applies to non-transactional tables like MyISAM, not just to FRM files. MyISAM doesn't have redo logs, so a non-blocking copy of MyISAM tables may result in an inconsistent backup. And that's why we have to copy MyISAM tables under a global read log. Now, let's talk about the basic usage of XtraBackup. So the most basic way to create a backup is to use the InnoBackup X script and specify the destination directory to store backup data. InnoBackup X also accepts many command line options. The most frequently used options are defaults file, which accepts a path to a server configuration file. In particular, it may be used to specify a non-standard data directory location, because XtraBackup assumes the data directory to be a var/lib/mysql by default. So if your server is configured with a different location, you need to get to let XtraBackup know by passing the server configuration file with the defaults file option. You may also want to specify connection parameters that XtraBackup should use to connect to the server, like user, password, host, or socket. Now, let's take a look at the second backup stage, that is preparing the backup by applying transaction log. You can execute the stage by invoking InnoBackup X with the apply log option, and you also need to specify a backup location. In this mode, InnoBackupX uses the XtraBackup binary to start a mini-DB instance and essentially perform data recovery by applying log records from the XtraBackup log file to the data files. So, yes. And this is the most basic usage scenario for XtraBackup. Any questions so far? No questions? Okay, and by the way, if you do have any questions, don't hesitate to interrupt me and ask at any time. I don't mind doing it more interactively. Okay, so now let's talk about streaming backups. So far I've been talking about local backups, which allow you to get a local copy of data that is on the same host or a remote host using an NFS mount, for example. So the idea behind streaming backups is to make it possible to manage backup data using the Unix pipeline mechanism. So one could, for example, pipe the backup stream to a gzip utility or bzip2 to compress it, and then pipe the resulting stream to SSH to transfer it to a remote host, for example, and then possibly uncompress it on the remote host, and so on. So we introduced the streaming backups functionality, which is unique to XtraBackup. It is not supported by other physical backup solutions for MySQL, like MySQL Enterprise Backup, for example. And it works like this. In the streaming backup mode, InnoBackupX basically executes the same steps that it does in the local backup mode. But instead of storing the files locally, both InnoBackupX and XtraBackup and the XtraBackup binary send the results to the standard output using the tar file format. So the resulting data stream can be unpacked with the tar utility. And even though the basic steps are the same as for a local backup, streaming data dynamically implies some challenges with how it is processed internally. I will cover this later. Now, to start the streaming backup, you have to pass the --stream equals star option to InnoBackupX. You also have to specify a directory. And even though XtraBackup will not use that directory to store data files, as it would do with the local backup, it will still use that directory to store temporary files. For example, a temporary copy of the transaction log file. So the directory part is still required. So as I said, you can use the standard tar utility to unpack files from the stream generated by XtraBackup in the streaming backup mode. The only important difference here from a normal tar usage is the -I option. This option tells the tar utility to ignore end-of-file markers in the stream. It is required because the tar stream generated by XtraBackup is basically is produced by merging multiple individual tar files together. So there may be end-of-file markers in the middle of the stream. And if you don't specify this option, tar will stop processing the stream after the first file, so you'll end up with an incomplete backup. So here's a few interesting use cases for streaming backups. First of all, you can compress your backups with external utilities like gzip or bzip2. You can also encrypt backups using OpenSSL, for example. You can also do remote backups by sending the stream to SSH and possibly unpacking it simultaneously on the remote host with the tar utility. And you can utilize the power of the Unix pipeline mechanism by combining all these use cases together. For example, this command on the bottom of the slide creates a compressed, remote, encrypted backup. So that's how streaming backups can be used. Questions? Okay. Now let's talk about incremental backups. An incremental backup is a copy of changes in the data since a specified point in time. So what InnoBackupX does in the incremental backup mode is basically the same steps that it do for a normal backup, except that instead of copying the entire NETWAYS tables, it only copies pages changed since a specified point in time. And the mechanism which is used to implement incremental backups is based on the LSN concept. LSN stands for log sequence number, and a very simplistic definition of it is that it's a number that defines a point in time when a page was last updated. So what XtraBackup does when creating an incremental backup is it scans all data files and copies all pages with log sequence numbers greater than the specified LSN. So by using an incremental backup with LSN of the last full backup, for example, you can copy all changes since the last full backup. It is also worth mentioning that this method of doing incremental backups works only for InnoDB tables. For my ISM tables or other non-transactional tables, XtraBackup creates full table copies in the incremental mode. So here's the basic command to start an incremental backup. As you can see, in addition to the incremental backup directory, you have to use the --incremental option and the incremental base dir option and pass a full backup directory as its argument. The full backup directory is required to determine the starting log sequence number for the changes that should be included into the incremental backup. XtraBackup reads that value from the XtraBackup checkpoints file, which is stored in every backup directory created by XtraBackup. So this true LSN value is, in this example, is the log sequence number of the latest modification included in the full backup. So when you pass the full backup directory with incremental base dir option, XtraBackup will read true LSN from this file and use it as a starting point for incremental backup. Now, in order to restore from an incremental backup, you should first merge the incremental changes to the corresponding full backup, and then restore the updated data set. Merging incremental changes is a two-step process. First, you have to prepare the full backup by using the apply log option and passing the full backup directory. But an important difference from when preparing a full backup before merging an incremental one is that you also have to use the redo only option. The reason is that normally XtraBackup also rolls back uncommitted transaction when preparing a backup. But when you're going to apply an incremental backup later, transactions that were not committed at the full backup time are already taken into account in the incremental changes. That is, no matter if incremental backup will if those transactions were rolled back or committed, the updated pages will be in the incremental backup. So you have to skip the rollback phase when preparing a full backup by using the redo only option. And once the full backup is prepared, you can then merge the incremental changes by passing the incremental dir option to InnoBackup X and pass the incremental backup directory.
Question?
Yes, sure.
Can this be combined with the streaming mode? Because the backup directory must be local, I guess.
Yes, streaming incremental backups were not possible with XtraBackup 1.6, but we fixed this so you can do streaming incremental backups in XtraBackup 2.0. I will get to it later. Okay, so now let's talk about the table export feature of XtraBackup. It is sometimes necessary to restore individual InnoDB tables from a full backup to another server instance, or maybe to the same server instance. And restoring individual MyISM tables to another server is simple, right? You can just copy MyISM files to the server, and that's it. Restoring the full backup to another server is also easy. You can just copy the full backup directory to another server instance, and then you can start the server with this new data directory, and that's it. But if you only need specific InnoDB tables to be restored, you can't just copy them. Instead, you should use the table export feature provided by XtraBackup, and then you can use the improved table import feature available in Percona server. So those features work in combination. And this, of course, is only possible with multiple InnoDB table spaces. That is, with the InnoDB file per table option enabled. Because if a table resides in the shared system table space, there is no way you can extract it and copy it to another server. You can only copy the entire system table space. But why does it have to be that complex? Why can't you just copy a table that is an IBG file to another server? The reason is metadata. As you know, InnoDB stores meta information describing tables, table spaces, indexes, and so on in a series of internal tables called data dictionary. and that meta information, the data dictionary resides in the system table space. So the information in the data dictionary must match whatever is actually stored in IBD files. If the information in the data dictionary and an IBD file don't match, NETB will complain about data corruption and crash with all kinds of scary messages. So what the table export feature of XtraBackup does is it dumps index metadata from every IBD file on the prepare stage and stores it in a special file called, which has the .exp extension. And then Percona server uses that .exp file when importing the table to update pointers and IDs in both the data dictionary and the data files.
Does this also apply to MySQL Server or MariaDB, because you're explicitly talking about Percona server at this point?
Yes. The improved table import functionality is not available in the standard MySQL server from Oracle, and I'm not sure if MariaDB has merged this functionality from Percona server. I have to check the code to answer that.
After all, these not supported on MySQL server.
Yes. Yes, I will be talking about the standard MySQL server in a couple of slides. So here's an example of the table export feature in action. The only difference with the normal backup procedure, backup prepare procedure, is the -- export option, which you have to pass to XtraBackup. And when that option is present, XtraBackup reports that it's also creating .exp files for every table, like customer.exp in this example. And it also prints index information that will be stored in that file. In this example, the table had 4 indexes, including the primary key, and it also prints IDs and root page offsets for each index. So this is basically the information that will be stored in the .exp file. Now, to import the table exported with the export option, you must be running Percona server, because, as I said, the improved import functionality is not available in the standard MySQL server. So with Percona server, you can restore the table either to the same server instance where the backup was created, or a different server instance. And in case you are restoring it to a different server, you have to first create a table with the same definition to create an FRM file for that table. Then you should disable foreign key checks by setting foreign key checks variable to 0. It's only required if you have foreign key constraints referencing that table. Otherwise, you can skip the step. You should then drop the existing table space by using alter table discard table space statement. Then you can copy the IBD file from the backup directory to the data directory on the server. After that, you can import it to the server using the alter table import table space statement. But before that, make sure you have enabled the improved import feature functionality, if it's not already set in the server configuration file. This feature is controlled with the NETB import table from XtraBackup option in Percona server 5.5 or NETB expand import in Percona server 5.1. And after the import table space statement finishes, the table is ready to be used, and you can enable the foreign key checks back. Now, what about the standard MySQL server? As I said, the improved table import functionality is only available, is not available in the standard MySQL. So the only thing you can do with the standard MySQL server is to restore a table to the same server instance where the table was created. Otherwise, table metadata will be different. And another serious limitation is that between taking a backup and the import operation, there must be no DDL operations like drop table or create table or truncate or alter on this table. So, for example, to import the customer table in this specific limited case, the procedure looks like this. You run alter table customer discard table space. Then you copy customer IBD from the backup directory to the database directory. And then you should run alter table customer import table space to import this table. But in this limited case, that is when restoring to the same server and there have been no DDL operations on the table, you don't even need the export feature of XtraBackup. You can just take the IBD file and copy it to the database directory. So that's how the export feature works. The next important and frequently used feature of XtraBackup is partial backups. It allows you to back up individual tables or schemas as opposed to backing up the entire data set. And once again, it requires multiple InnoDB table spaces, that is InnoDB file per table enabled, in case you need to do partial backups of InnoDB tables. Because if all InnoDB tables are in the shared table space, you can only back up the table space as a whole. You cannot extract individual tables from it. Which is another hint that if you need some flexibility with managing your backups and InnoDB tables, you should consider enabling multiple table spaces. InnoDB multiple table spaces. Now, restoring from a partial backup is absolutely the same procedure as restoring individual tables from a full backup, which means the restore procedure has the same limitations with the standard MySQL server. You can only restore to the same server instance where the backup was taken, and there must be no DDL operations on affected tables. And those limitations do not apply to Percona server when using the improved table import feature. There are many ways to specify which tables or databases you would like to include to a partial backup. It also depends on whether you're using the InnoBackupX script or the XtraBackup binary, which is a bit unfortunate, but they're going to fix this in the future by merging InnoBackupX and XtraBackup into a single binary. But for now, you have the following options. When using the InnoBackupX script and creating a streaming backup, you can specify databases and tables with the double dash databases option, which accepts a space-separated list of databases. And for each databases, you can optionally specify a table name after the dot. For example, using employees space sales.orders as its argument will make InnoBackupX back up the entire employees database and only the orders table from the sales database. If you're taking a local backup that is without streaming, you can use either the tables file option or the include option of InnoBackupX to specify tables to be included. Tables file takes a path to a file which has a very simple format. It contains table specifications in the database.table form, line per line. And the include option is the most flexible one. It allows you to use regular expressions to specify databases and or tables. For example, this expression will include all tables with names starting with reports in databases called database 1 or database 2. And when using the XtraBackup binary directly, that is without the InnoBackupX wrapper, you can choose between the tables file option, which has absolutely the same syntax as the same option in InnoBackupX, and there is also the tables option, which accepts regular expression, so it's equivalent to the include option in InnoBackupX. So these are the options that you can use to select which tables or database schemas are included in a partial backup. Now, preparing partial backups is not any different from preparing full backups from the user perspective. Just make sure to specify the export option if you're going to restore your partial backup to a different server, in which case you also need to be running Percona server. The only difference is in the XtraBackup output. Since some tables are missing in a partial backup, XtraBackup warns you that it's unable to find some tables, so they are being removed from the data dictionary. Like in this example, I created a partial backup of the customer table. So when preparing this backup, XtraBackup could not find the stored table, so it was removed from the data dictionary as seen from the log. But the customer table was successfully prepared to be restored later. And since I was using the export option, XtraBackup also created a meta information file describing indexes in the customer table. Okay, so as I said previously, to restore from a partial backup, you should follow absolutely the same procedure as to restore individual tables from a full backup. That is, for non-InnoDB tables, such as MyISAM, you can just copy files to the database directory. And for InnoDB tables, if you're restoring to the standard MySQL server, you should use alter table, discard table space, and alter table, import table space statements. But the limitations are the same. It must be the same server instance where the partial backup was taken, and there must be no DDL on unaffected tables after taking a backup. And in case you want to restore to a Percona server instance, you should use the table export functionality of XtraBackup and improved import in Percona server to avoid limitations. So make sure you enable those features with the corresponding options. Yes?
The limitation you're talking about, truncating, etc. Isn't it only a counter in a DB? You maybe should skip if you want to import a backup and make a backup, but then you truncate the table and you can't import it because there's ID counting after.
Yes, if the table has no foreign key constraints, truncate table is internally mapped to drop table plus create table. So yes, the ID will be different, and you can restore it. If you're using the standard MySQL server, you can restore it from a backup. Now let's talk about performance-related features in XtraBackup. One of the frequent problems with backup software is that it may sometimes have a significant overhead, stealing operating system resources or hardware resources from other applications running on the same host. So even though XtraBackup is the least intrusive backup solution available for MySQL, it's a hot backup tool after all. It also consumes resources like CPU cycles or disk I/O capacity, or if you're backing up to a remote host, it also may consume network bandwidth. So XtraBackup provides a couple of features that can be used to minimize its footprint on the server where it's running, so that taking a backup doesn't slow down the MySQL server considerably. One of these features is I/O throttling, which allows you to limit the number of I/O operations per second performed by XtraBackup. This feature is controlled by the --throttle option of the XtraBackup binary. And the option value is specified in 1 megabyte units. And it works like this. XtraBackup copies init.b files in 1 megabyte blocks. So this feature actually limits the number of copy operations per second. When XtraBackup hits that limit, it suspends the file copying activity until the next second. So for example, a value of 1 will make XtraBackup copy at most 1 megabyte of data every second when taking a backup, and then wait for the next second to begin to continue copying data. Another frequent problem with backup software is that it may have a negative impact on the file system cache. Because when a backup utility copies data, the data gets cached by the operating system by default, evicting other data from the file system cache and possibly preventing it from being cached again. As a result, the file system cache may end up filled with cold data. That is the data that is never going to be accessed again after taking a backup. And this problem is also especially painful for servers with many MyISM tables, because MyISM relies on the file system cache to cache data files. And caching unnecessary data also puts additional pressure on the virtual memory subsystem and may also result in swapping. So XtraBackup solves this problem by using a special system call provided by the Linux kernel, which is called POSIX-fadvice. When this system call is invoked with the POSIX-fad don't need argument, it tells the kernel that the application is not going to reuse the specified range of bytes in a file, so it doesn't make sense to cache it. So XtraBackup uses that system call to avoid thrashing the file system cache with backup data and thus slowing down the MySQL server, especially MyISM tables. Now the good thing about this feature is that it's fully automatic. There is no option to enable it. It just works automatically on Linux. But a small warning: even though the feature has been available for quite a while, there was a bug in implementation which prevented it from working properly in XtraBackup 1.6, and we noticed it recently and fixed in XtraBackup 2.0. Another performance-related feature in XtraBackup is parallel file copying, or just parallel backups, as it's called in the documentation. What it does is it makes XtraBackup copy multiple files concurrently, rather than one by one. It works by creating the number of threads specified with the parallel option to in the backup X or XtraBackup. Then, after the necessary number of threads has been created, each thread is copying one file at a time. So, for example, with 4 parallel threads, it will be copying at most 4 files in parallel. So using this feature normally results in higher disk hardware utilization. And the best performance improvements can be seen on SSDs, which handle parallel I/O better. But it may also result in faster backups even on traditional disk drives, or even on low-end single drive hardware. Because with more parallel I/O requests, the I/O scheduler in the kernel is able to merge more requests and reduce the number of disk seeks. Yes?
Is parallel copying supported for skipping backups?
Yes. In XtraBackup 2.0, yes. In XtraBackup 1.6, it wasn't supported. Does it answer your question?
I'm just wondering how you do it. You're outputting what's basically a guitar file.
Yes. Yes. TAR streams don't support concurrent streaming, so we had to introduce another streaming format for in XtraBackup 2.0, which allows parallel file streaming. Yeah, so the I/O scheduler in the kernel is able to merge more I requests when the parallel file copying is in action. However, it all depends on specific hardware and workloads combination. So your mileage may vary, and we recommend running some benchmarks before using this feature in production. So now I'll be talking about the new features introduced in XtraBackup 2.0 that we released about 3 weeks ago. The major new features in that release are streaming incremental backups, parallel compression, the XBStream file format and utility to manage streams in that format, and LRU dump backups. So one of the problems solved by XtraBackup 2.0 is streaming incremental backups. Streaming backups are typically used to back up to a remote host by streaming data to SSH, for example. And you can use them in XtraBackup 1.6 to stream full backups to a remote host. But streaming incremental backups did not work for the following reasons. InnoBackupX used external utilities to generate TAR streams. So in case of streaming backups, it didn't invoke the XtraBackup binary. But on the other hand, the XtraBackup binary was essential for incremental backups because it scans NZB data files to compare LSNs and generate delta files. And that's why streaming incremental backups didn't work in XtraBackup 1.6. But in XtraBackup 2.0, the XtraBackup binary can produce data streams on its own, either in the TAR format or in the new streaming format, which is called XBStream. So it can also scan NZB files and stream data at the same time. So you can now create streaming incremental backups in any backup mode. Another new feature in XtraBackup 2.0 is built-in compression. Disk space is often a problem, even for our biggest customers, probably because data is usually growing all the time, and it's hard to scale your hardware infrastructure to keep up with the growing disk space occupied by your data set and consequently your backups. So that's why people are often looking for ways to reduce the disk space occupied by their backups, and data compression is obviously the first thing that comes to mind when you want to achieve that. You can, of course, use external utilities to compress backups produced with XtraBackup, but this approach has some serious limitations. I will be talking more about them later, but those limitations is the reason why we have implemented a built-in compression facility in XtraBackup 2.0. So what's the problem with using external utilities to compress backups? Well, with local backups, that is when backups are stored on the same host where the server is running, your only option is to create an uncompressed backup first and then use a compression utility like gzip or bzip2 to compress backup files. Which means there must be sufficient disk space to hold an uncompressed version of the backup before it will be compressed with the compression utility. Which is, of course, not always the case. The whole point of creating a compressed backup might be that you don't have enough disk space, right? Another drawback of creating a local backup is that essentially you have to read and write your data twice. First to create a backup, to create backup files, and then to compress them, which of course may be a problem with large data sets. Now, with streaming backups, using compression utilities to compress the output stream, the output backup stream is also problematic. Problem number one is that most popular compression utilities like gzip or bzip2 are single-threaded, which means they can only use a single CPU core for compression, which is, of course, quite unfortunate these days when even mobile phones have multiple CPU cores. And there are some alternatives, like, for example, there's a multi-threaded version of gzip called pigs, which can use multiple CPU cores, but decompression is still single-threaded. There's no way to uncompress a gzip archive with multiple CPU cores. And problem number 2 is that since you are compressing the entire stream rather than individual files, you have to uncompress the entire backup later, even if you only want to extract a single table from your backup, which of course may also be problematic in some cases. So to solve all of those problems at once, we introduced built-in compression in XtraBackup to 0. Now, both InnoBackupX and the XtraBackup binary accept the double-dash compress option, and it uses the QuickLZ library to do compression. The reasons for choosing that library instead of some more popular ones is that QuickLZ was designed, implemented, and optimized to handle large data volumes efficiently. Quoting their website, is the world's fastest compression library, reaching more than 300 megabytes per core. And they also have some benchmark results on their website to prove that. It also provides good compression ratio. Of course, it depends on the data, but in my tests, I got about 8-fold compression. The native archive format for the QuickLZ library is QPress, so you have to install an additional utility to uncompress your backups. And an important thing about compression in XtraBackup is that each file in the resulting backup is a single file QPress archive. It was implemented like that to provide more flexibility with managing backups. So that to restore a single table, you don't have to uncompress the entire backup to restore a single table, as you would have to do with TarGZ, for example. Another cool thing about built-in compression in XtraBackup to 0 is that it's parallel. That is, you can use multiple threads and consequently multiple CPU cores to do compression. The number of threads to use is controlled by the compress threads option. You can also use parallel compression in combination with parallel file copying. In this example, I tell XtraBackup to use 4 file copying threads and 8 compression threads. So it will copy at most 4 files concurrently, and then use at most 8 CPU cores to compress them. So let's move to another new feature in XtraBackup to 0. It is called LRU dump backups. But before explaining it, let me explain LRU dumps first. It's actually a Percona server feature, so if you don't use Percona server, you might not be aware of it. And here's a brief overview. So LRU dumps is a feature available in Percona server. It allows you to greatly reduce the warm-up time for the InnoDB buffer pool after a server restart, or a crash, it also happens. And it works like this. InnoDB employs the least recently used algorithm to manage pages in the buffer pool, which means the buffer pool is organized as an LRU list, hence LRU in the feature name. What the LRU dump feature does is it periodically dumps page IDs from the LRU list to a special file named IB-LRU dump. Note that it doesn't dump the entire page contents, it only dumps page IDs, which is enough to locate pages and the data files later and read their contents back. So the IB-LRU dump file is much more compact than the actual buffer pool. For example, for a 16 gigabyte buffer pool, the size of the dump file will only be around 8 megabytes. So on restart, Percona server automatically loads IB-LRU dump if present, and rebuilds the buffer pool contents by fetching pages specified in the dump file. As a result, the buffer pool warms up in minutes rather than hours or even days, as sometimes happens with servers with large amounts of memory and huge buffer pools. And another small but extremely useful improvement in XtraBackup to 0 is that it automatically detects and includes to the backup the IB LRU dump file. That is the dump file produced by the LRU dumps feature. Which means that after restoring from a backup, no matter if it's the same server instance or a different one, the buffer pool will get to absolutely the same state as it was when taking the backup in just a few minutes. Just make sure to enable the server feature so it reads and restores the buffer pool on startup. In Percona server 5.1, this feature is controlled by the InnoDB auto LRU dump option, and in 5.5 it was renamed to InnoDB buffer pool restore at startup. Yes, some pointers to further reading and communication channels that you can use to talk to us. We have documentation for XtraBackup that you can find at percona.com/doc/percona-XtraBackup. It isn't perfect, but it has become a lot better during the last few months, and we are improving it all the time. You can find information on XtraBackup packages available for download at the corresponding section on our website. We have a Google group called Percona Discussion, which is the main place to discuss all Percona software, including Percona XtraBackup. You can also find many Percona employees on the Percona IRC channel on Freenode. I'm also there, so feel free to ask questions. We also use Launchpad to track XtraBackup bugs and manage releases. So here's the link to the XtraBackup project on Launchpad. It's launchpad.net/Percona XtraBackup. And there's also a direct link to the bug reports section. If you think you found a bug in XtraBackup, please let us know. Yes, a couple of general information slides. First of all, Percona is hiring. We are looking for consultants, support engineers, and software developers. So if you're interested, you can visit this link for more information. And I'd like to let you know that the next conference in the Percona Live series will take place in New York in October 1st and October 2nd. Percona Live conferences are technical summits focused on MySQL. And the call for papers is open now. So if you feel interested in participating either as a visitor or as a speaker, you can get more information by visiting percona.com/live. Any questions on XtraBackup in general?
Regarding the throttle output, so only 1 megabyte per second. Is this at the first 10 milliseconds you write this 1 megabyte and then you do nothing until the second is done?
Yes.
Or do you spread it over the second?
No, it just does one copy operation and then it waits for the next second.
Okay.
If it takes just 1 millisecond, then yes.
Migration from 1.6 to 0. Are there any problems?
No, they're fully compatible from the from the interface point of view. If you don't need new features, then your previous scripts to automate XtraBackup will just work with XtraBackup to 0. Yes.
You said table restore is for MySQL for Priority only available if I use it on the same server.
Yes.
Will it also work if I start a new server from scratch? When I build up my new server?
No, it must be the same server instance, so that the IDs in the data dictionary must be the same. And if you start a new server instance from scratch, then most likely the IDs will be different. So it won't be able to import your table from the backup. That's the limitation. I think MariaDB has imported this functionality, so it's also available. It must be available in MariaDB too.
You also plan some enterprise management, web GUI, whatever stuff. If you have several Percona or MySQL installations, because currently this is everything. Okay, it's a shell tool that I can use, but it's for a bunch of servers, several hundred servers. It's
Yes. No, we don't currently have any plans to provide any automation tools around XtraBackup, but we rely on third parties to build them. And in fact, there are multiple. Well, there's at least one project that's worth taking a look at. It's called XtraBackup Manager, and it's developed by a Facebook employee. It provides automation and scripting around XtraBackup, like doing backups on a schedule, or implementing a specific backup rotation strategy, stuff like that. So I don't think it has a GUI, but it's written in PHP, so maybe it does provide some some GUI functionality. Yes.
I just want to praise the product because we're using it to back up think of with about 600, 700 gigabytes and works fine. Recovery is.
That's good to know. Thank you. I'm glad you like it. No more questions? Okay, so thank you.
Thank you, Alexey. Now we have a lunch break until 2 o'clock. And next talk in this room